Students, welcome to the lecture number 8 of chapter 6. In previous lecture, we have completed all the questions from exercise 6.1, and in this lecture, we will start a new concept that is known as parallel lines. As I have told you, what are the parallel lines? Two lines are said to be parallel if the perpendicular distance between them is fixed. That means the distance between two lines at any instance is fixed, and the second condition is if we extend them in any direction, then they will never meet each other. This is the definition of parallel lines. For example, if there are two lines AB and CD, if the perpendicular distance means the minimum distance. Okay, perpendicular distance is the minimum distance. If the distance between these two lines at any instant, okay, at any point is fixed. It means if it is 5 centimeter, then this must be 5 centimeter. This must be 5 centimeter. This must be 5 centimeter. This is the first condition. And the second condition is that if we extend them in any direction, if this line is extended in this direction and also in this direction, and if CD line is extended in this direction and in this direction, then they will never meet each other. Then such lines are known as parallel lines, and we represent them AB parallel to CD. Understood? But if the distance between them is not fixed, is varied means if it is a line AB and there is another line CD. Now you can see the distance between these two lines at this position is more than this position. Here the distance between them is very less, but here the distance between them is bigger or larger. Hence, if you extend them, then they will meet each other at any point. Right? Here these two lines meet each other. Hence, these two lines are not known as parallel lines. So you can write AB line is not parallel to CD, and these two types of lines are known as intersecting lines. Okay, these are known as intersecting lines, and these are known as parallel lines. So our today's topic is parallel lines and its other criteria. So let us first understand the basic criteria in order to be parallel lines, as well as we will study what is the transversal line. When the transversal line is drawn, then how many angles are formed? Okay, this concept should be taught in this lesson or in this lecture. Okay, so let's start with transversal line. Okay, so first of all a question arises, what are the transversal line? So the definition is a line is said to be transversal if it caught or it intersects two or more than two lines at distinct point. Again, I am writing this definition. A line is said to be transversal if it intersects. Intersect means if it chords, or you can say chords, two or more than two lines at distinct point. Distinct means different point, not in one common point. Okay, at distinct points. So simply, for transversal line, a line should intersect two or more lines. Suppose there are two lines, okay, AB and CD. Now we will draw another line which intersect these two lines at how many points? At two distinct points. Okay, this line this is P Q. Now this line intersect AB at a given point. Suppose this point is O. And this line PQ is again intersect this line CD at another point. Suppose this point be M. Now what you find? You find that PQ line intersect line AB and line CD at two distinct points. That's why this line PQ is known as transversal line. Okay. So here the line PQ is transversal. Understood? Transversal line. Okay. Another example. Suppose there are three lines. 1, 2 and 3. AB, CD, EF. You draw another line PQ. Now you see the line PQ intersect the line AB at a point. Suppose this point is M. Now this PQ line is again intersect the line CD at another point. This is suppose M. This line PQ is again intersect the line EF at another point. Suppose this is O. Hence you find the line PQ intersects the line AB, CD and EF at three distinct points, not in same point. You have to remind it, three distinct points. What are the points? M, N and O. Hence PQ is known as transversal line. So in order to be transversal, the line should intersect at least two lines at two distinct points. If there are more than two lines, then it is not any problem, but it must intersect at least two lines. Okay. One more example. Suppose this is a line. Okay. A, B. This is another line. C, D. Okay. Now we draw a line PQ which intersect both the line CD and the line AB. Now tell me whether AB is a transversal line or not. Okay. See, here the line PQ intersect the line CD at a given point. So this point is O. Similarly, this PQ line intersect AB at another point. This point is Q. Sorry, this is not Q. This is suppose M. So you find that PQ line intersect AB and CD at two distinct points. Okay. We are not talking about the line AB and CD. Either they will meet or they will not meet. That doesn't matter. But the thing is, the line PQ should intersect these two lines at distinct points. At least two distinct points. So here the line PQ is also known as transversal line. Okay. So in all the three cases, the line PQ is known as transversal line as it intersects the different lines at distinct points. Now, one more example let us take. Suppose there is a line AB. There is another line CD which intersects the line AB. Okay. Now, to these two lines, another line PQ intersect. PQ. Now tell me whether PQ is transversal line or it is not a transversal line. Let us find. See, the line PQ, okay, intersect the line AB at a point, suppose O. So here intersecting point is O. Similarly, that line PQ caught or intersect the line CD at same point O. Here also it cuts the line CD at O. So what you find here? You find the line PQ intersect AB and CD at a common point, not at distinct points. Okay. Here the point of intersection is common. Here the point of intersection is 3 points. Here the point of intersection is 2 points. But here the point of intersection is 1 common point. So PQ line is not a transversal line. Then what is the name of this PQ? This is known as concurrent lines. What is it? This is known as concurrent lines. I have told you the definition of concurrent lines. Or you can say these are known as intersecting lines. Okay. This is not transversal line as it does not cut or doesn't intersect the two lines at distinct point. It cuts the line at only one common point. Okay, so this is the basic definition of transversal line. Now you can easily find what is the transversal line and what is the concurrent line or intersecting lines. Okay. So as we have discussed, what is a transversal line? A straight line which intersect two or more than two number of straight lines at distinct points, then that line is known as transversal line. And you can see there are two lines AB and CD. Now these two lines are being intersected by another line PQ at two distinct points M and N. So this line PQ is known as transversal line. Okay, it is known as transversal line. Clear? Now tell me, whenever this transversal line intersects these two lines at two distinct points, then totally how many number of angles are formed here? Look at this. Totally how many number of angles are formed when this line intersects these two lines? Tell me. First consider this line AB. Now this line AB is intersected by the line PQ at M. Then how many angles are formed here? 4 angles are formed. 1, 2, 3 and 4. 1, 2, 3, 4. Okay. So here you have 4 angles formed by the transversal line when it intersects the line AB at the point M. Similarly, when the same line PQ intersects the line CD, then here how many angles are you formed? Then here also we have how many angles? 4 angles. This is 5, 6, 7, 8. So we get whenever a transversal line intersects two other lines, then totally 8 angles are formed. Okay. So totally 8 angles are formed. Now you can see out of the 8 angles, there are some angles which lies outside these two lines. See, if this is the line AB and this is another line CD. Let's see how many angles which lies outside these two lines. 1, 2, 7 and 8. So totally there are 1, 2, 3, 4. 4 lines which lies outside these two lines. Okay, and they are known as exterior angles. Okay, so what are the exterior angles? The angles which lies outside these two lines are known as exterior angles. So here 1, 2, 7 and 8 are known as exterior angles. So the exterior angles are 1, 2 angle, 7 angle and 8 angle. Right? Next, as you can see, in between these two lines there are also 4 angles. 3, 4, 6, 5. See, if it is the line AB, it is the line CD. Then in between these two lines, how many angles are there? 1, 2, 3, 4. 4 angles are there. 3 angle, 4 angle, 5 angle, 6 angle. Now these 4 angles are known as interior angles. Okay. What are they? They are known as interior angles. So here angle 3, angle 4, angle 5 and angle 6 are known as interior angles. So the angles which lies in between these two lines are known as interior angles, and which lies outside these two lines are known as exterior angles. Now, except these two types of angles, there are also another 6 types of angles. Okay, let us understand them and know them periodically. So let us understand the first angle. Consider the line AB and the line PQ. Forget about CD. Forget about the line CD. Simply consider the line PQ and the line AB. Here PQ is a straight line. AB is also another straight line. Okay, like this. This is PQ. Okay, and this is AB. Forget about CD. Okay, we will consider it later. Now, whenever two straight lines will intersect each other, then according to the theorem 6.1, you know total how many angles are formed? 4 angles are formed, and out of these 4 angles, two pair of opposite angles are known as vertically opposite angles. We have discussed it in theorem 6.1, right? So here totally how many angles are formed? 4 angles are formed. 1, 2, 3, 4. And out of these 4 angles, two pair of opposite angles are known as vertically opposite angles. So here it is the common vertex. Then this angle and this angle are known as vertical opposite angles. Okay? And this angle and this angle are known as also vertically opposite angles. Okay? So the next type of angle is vertically opposite angles, VOA. As you can see here, 1 and 3, one angle and 3 are vertically opposite. One pair, 2 and 4 are also vertically opposite. Right? Next, if you consider the line CD and the line PQ, okay, the line CD and the line PQ, forget about the line AB. Okay, now whenever the line PQ intersect the line CD, totally how many angles are formed here also? 4 angles are formed. And out of these 4 angles, the opposite pair of angles are known as vertically opposite angles. So here the angle 6 and 8 and angle 5 and 7 are known as vertically opposite angles. Understood? So here you find the angle 6 and 8 and 5 and 7 are also vertically opposite angles. Hence, how many number of or how many pair of vertically opposite angles you find? You find 1, 2, 3, 4. 4 pair of vertical opposite angles whenever a transversal line intersect the two lines at two distinct points. Understood? This is the third type of angle. And now we will consider another type of angles that is known as corresponding angles. So the fourth type of angle is known as corresponding angles. Okay? So let us first understand what is the meaning of corresponding angles. Right? So two non-adjacent angles are said to be corresponding if it follows two conditions. Again I am telling you, the definition is two non-adjacent angles. There is a word non-adjacent. Non-adjacent. Okay? Non-adjacent means the two angles must not be adjacent. Right? So the two non-adjacent angles are said to be corresponding if it follows two conditions. What is the first condition? The first condition is that the two angles should lie on same side of transversal line. Okay? So let us understand the first sentence clearly. So it gives you that the two angles, that means the two non-adjacent angles, should lie, okay, on same side of transversal line. These two words should be keep in mind. Same side of transversal line. It means what? It means since in this figure PQ line is a transversal line, okay, suppose this is the transversal line. Now tell me, this transversal line has how many sides? It has two sides. This is the right hand side and this is another side known as left hand side. So a transversal line has two sides, right hand side, left hand side. Now according to the definition, the two angles should lie on the same side. Means suppose one angle lies in this direction, then another angle also lies in this direction. Okay? If one angle lies in this direction, then another angle must lie also in the same direction. Okay? So the two angles must lie on the same side. If one angle lies in this side, another angle must lie in this side. They should not be opposite direction. One should not lie in this direction and one should not lie in this direction. No, they should lie in the same direction. Clear? This is the first definition or first condition. Okay? Let us write the second condition. The second condition is that out of the two non-adjacent angles, one angle should lie towards the exterior side and another angle should lie towards the interior side. Okay? First write it. One angle should lie towards exterior, okay, and another towards interior. Okay, we will understand it. See, suppose this is the transversal line and the two non-adjacent angles should lie in this direction. We will assume it. Clearly understood? Now, according to the second condition, out of the two angles, one angle should lie in the exterior side or exterior direction. See, here in this direction, how many angles we have? We have 4 angles. 1, 4, 5, 8. Okay, if we consider this angle, angle 1. Now, angle 1 lies towards exterior side. Yes or no? Yes. Then what will be the second angle? The second angle should lie towards interior. Right? We consider angle 1. Now, towards the interior, we have two angles. Angle 4 and angle 5. Now, which angle should we choose? Can we choose angle 4? No. Why? Because if we choose angle 4, then angle 1 and 4 will be adjacent. But it is denied the definition of corresponding angle. According to the corresponding angle, you have to choose two non-adjacent angles. So you cannot choose angle 4. So we have to choose angle 5. Now angle 5 lies in the interior side. And both angle 1 and angle 5 lies towards in this direction. Hence angle 1 and angle 5 are known as corresponding angles. Understood? So here angle 1 and angle 5 are corresponding. Okay? Angle 1 towards exterior, angle 5 towards interior. And they lie in the same side. Next, again consider 1, 2, 3, 4. 4 angles towards this direction. Now you can see the angle 8 also lies towards the exterior side. Yes or no? Yes. Now consider another angle which lies towards the interior side. This angle. Okay. So here the angle 8 and the angle 4 are also corresponding because they lie in the same side and one lies towards the exterior and one lies towards the interior. Clearly understood? So angle 8 and angle 4 are also corresponding angles. Okay. Next, if you consider this side angles, then how many angles we have? 1, 2, 3, 4. 4 angles. Out of the 4 angles, the angle 2 lies towards the exterior. Then angle 6 lies towards the interior. So these two angles are corresponding angles. So angle 2, angle 6 are corresponding. Next, angle 7 lies towards the exterior. Angle 3 lies towards the interior. So angle 3 and angle 7 are also corresponding angles. Angle 3 and angle 7 are also corresponding angles. So here in this figure we have how many pair of corresponding angles? We have 4 pair of corresponding angles. Okay. See, if you consider these two lines and this is the transversal line, then this angle and this angle are corresponding because it lies towards exterior and towards interior and the same side. Similarly, this angle and this angle are also corresponding, and this angle and this angle are also corresponding, and this angle are also corresponding. So there are 4 pair of corresponding angles. Understood? This is the 4th type of